Alright, so this video is going to cover section 9.4 or parts of 9.4. This is just applications with the quadratic formula, or I don't want to use the word formula, but the quadratics, solving quadratics in general. So the first couple things I have is, what if you had a bunch of like a formula, like for example, I have, let me take this out of here, hang on. Okay, I have like V equals pi, that's a parenthesis, r squared plus capital R squared h. Something like this, and it says, well, solve for little r. So little r squared, so we have to use kind of the idea of square roots to get this final answer, and it's kind of a long process. The first thing is, right now we're being times by a pi and an h. Even though one's on one side, one's on the other, you can actually divide by pi h at the same time on both sides. That way they cancel here, right? And they're now over here. So I have v over pi h equals, now we just have little r squared plus big R squared. So we've gotten rid of pi and h by moving them over. Now I want to move over the big R squared so I can solve for little r. And I'm going to subtract that over. This is already here, so make sure when you subtract it that you write it after what was already there. So it's this minus r squared equals little r squared. Then from here I have to square root it. Here's what most people forget. When I take the square root, I have to do the plus or minus. So it's going to be the plus or minus square root of v over pi h minus r squared equals r. And I would love for us to be done at this point, because we solved for r, yay! And if it was a paper exam, I could give you, let me move this down a little bit, I could give you partial credit or most credit and say, yay, you figured out the idea. But they do not let you have pi h in the denominator because it's like having a square root in the denominator. So what I have to do is I have to subtract these two here. So I'm going to get a common denominator by multiplying this one over here by pi h on the top and bottom, so that I can get a common denominator. And so under here we're now going to have v minus r squared pi h over pi h equals r. Then I now can separate the square root and get rid of the pi h by timesing the top and bottom by the square root of pi h. So I'm going to move this way. So now we're going to have the square root of, plus or minus, the square root of v minus r squared pi h over pi h square root times by pi h times by pi h. That way you get pi squared h squared, which reduces right to just pi over h as our denominator. And when we times up here, that is going to make our pi squared and our h squared, and you have to multiply the v also by pi h. Kind of like distributing that by this one and this one. So here is our final answer. Plus or minus the square root of v pi h minus r squared pi squared h squared over h pi. Oops. Woo! Kind of ugly, but once you've seen it, you're like, oh, okay, hopefully. Not too bad. So it uses the idea of rationalizing the denominator to get your final version of that ugly thing. So there we go. Be careful when you type it in that you use caps where you need caps. So the next concept was, let's see. If you have a formula where it says something like the ball is projected, they do a lot of those ones, and it equals a formula, you're typically putting in a number and solving that quadratic. So a lot of those are pretty simple. but you have to ignore one of the solutions. So for example, if I have the formula f of x is equal to negative 16x squared plus 128x. So if this is my formula and it says a ball is projected upward from the ground, its distance is the feet from the ground in x seconds. So x is our seconds and the y value, or f of x, is going to be your feet from the ground. What time will the ball be at 213 feet from the ground? So at what time will it be at 213 feet? So remember, this is going to equal to your feet, and x equals your time. So when I'm given the 213, I have to put it in for feet. So I end up with 213. So you're either putting it in here or for the x. Typically it's for the y to make the problem a quadratic and a little harder problem. So from here I got to set it equal to 0 and use one of my methods to find my two solutions. So I'm going to minus the 213 over so that I have 0 equals negative 16x squared plus 128x minus 213. Then from here, these are ugly numbers, so I'm just going to use the quadratic formula. So a, b, c, you go negative of the b, so that's negative 128, opposite sign, plus or minus the square root of b squared. I like to square my b right away to make sure it's positive, so 128 squared is 16384 minus 4 times a times c, so you have lots of negatives in there you have to be careful of, all divided by 2 times a. Alright, so I'm just going to put this in my calculator. So that big number minus 4 times a negative 16 times a negative 213 is going to give me 2752. So I have negative 128 plus or minus the square root of 2752 all over 2 times 16 is 32, so you have negative 32. Whoop, that's kind of ugly. So I want time in terms of seconds. I want a decimal answer. I do not want an exact answer on this one. So therefore I have to find the decimal and calculate that out. So I'm going to put that in my calculator. I get what, 2752, that's going to give me about 52 here. So I'm going to have negative 128 plus or minus, I'm going to round it to 52.5. Or maybe, well, I could round it, yeah, let's just round it to 52.5, that'll work, over negative 32. So then we do it this way, negative 128, and then I'm going to do plus 52.5, get the answer, which is negative 75.5 divided by negative 32. So divide that by 32, I'm going to get about 2.4. Okay, let's do the other one. So negative 128 minus 52.5 is going to give me negative 180.5 over negative 32. So divide that and I get about 5.64 or 5.6. Okay, so here's my two answers. So then I have to decide which one's right and which one's wrong. A ball is projected upward from the ground. It is a distance of feet from the ground. What time will the ball be at? Oh, I guess it could have two answers for this one. Typically, one answer doesn't work. I could put them both back into my original and see if one gave me a negative answer. So let's try the 2.4. So negative 16 times 2.4 squared plus 128 times 2.4 is around the right answer. And then let's try 5.6. Negative 16 times 5.6 squared plus 128 times 5.6. Oh, they both work. So we have two solutions. Bing, bing. Usually one's negative and you cross it out, but that's kind of the idea of section 9, 4. Each problem is a little bit different, so you just have to work through them and maybe look through the examples.